It's past 9 o'clock. Out of respect for everybody's time, whether you're synchronous or asynchronous, we're going to go ahead and start videotaping the session for today, which is going to be the lab walkthrough session for this laboratory 2.7.2 OSPF single area, the first required laboratory for our capstone Cisco course. So this is the lab here in your curriculum under the student lab printout sections. Lab 2.7.2 is a Microsoft Word document, so print it out, and there are a few questions to answer there. Okay, so this is the particular lab that we're going to do today. And you notice that we have router R1 and R2, and these are the ones that we're going to run the OSPF routing protocol between. S1 and S2 in this lab, they're going to have you do a little bit of configuration to it. You know, like give it a host name and passwords and things of that nature. But actually, you could simply completely perform this lab by connecting the gigabit port of R1 to the gigabit port of R2, and just use one Ethernet cable and don't use the switches, and that would work just fine. But I'm going to go ahead and step through like it is. I'm going to be doing this on packet tracer, just so you can see how the options come out. Okay, so here we go to packet tracer, and let's create this topology. Okay, now we could simply go into the logical topology and drag the devices in to match the printout on the front of the lab, but I like to use to demonstrate using the packet tracer physical topology because it's so wonderful, and you get more of an intuitive, tactical feel for plugging in the cables. So I'm going to provision a rack, and I'll provision a second rack, and we'll put R1 and S1 in the first rack, and we'll put R2 and S2 in the second rack. So I'm going to go down and click on network devices and pick the router and put it in there, and pick the router and put it in there. Let me drag these power strips up to the top, get them out of the way, and we can pull this up so it's more visible. It's pretty even with each other. Okay, now let's provision a couple switches and put them in there. Move them a little closer to each other. See if I can get them lined up here. It's like splitting hairs. Okay, that's pretty even. Let's blow up the display a little bit. I'm going to move just a little bit here so the default expansion looks better. And let's see if I can blow it up even more. That's better. That's better. We can see the plugs and jacks a little more easily this way. Keep it down, pull it up here. We're recording. Yeah, we're recording. Okay. Is that as big as I can get it? Well, that's cuts off some of the switch. Okay, good. That looks good right there. So we've got the 4 devices configured. Excuse me, we haven't configured them. We just got it provisioned into the rack. We've racked and stacked. We got our electric screwdriver out. We screwed them into the rack. And now let's do the cabling. So on this particular first page of the lab, it shows that R1 is connected to S1 through an Ethernet cable. S1 is connected to S2 with an Ethernet cable. And S2 is connected to R2 with a third Ethernet cable. So let's pull those cables in according to that and make the connection take place. So I'm going to go to the jagged lightning bolt thing and choose a standard Ethernet cable, copper straight through cable. And that's supposed to go to G001. Here's G001 right here. Oops, G001. Here we go. And that goes to port 5 of the switch. Oh, good, we have a dangling cable. Now let's take port 1 of the switch 1 and connect that to port 1 of the second switch. And I'm going to use a crossover cable, which, hold on. Copper crossover cable. And I'm going to go from port 1 to port 1. And I made it so that this shows up as a different color. These days, with the advent of auto MDIX type electronics in most devices, you can interchangeably use either the straight through cable, which are more common, or crossover cable, and they'll work in either application. In the olden days, and this is still 20th century, we had to use a crossover cable to connect two switches together, or we'd have to use a crossover cable to connect two PCs together, or two routers together. We use straight through cables for everything else. So normally we plug everything to the switch with straight through cables, and the switch would make the connection for us. Okay, we have one more wire to connect, and we're going to connect from switch 2. We have to connect up to his router. So I'm going to go back to the regular straight through cable, and that goes from port number 5 of the switch to G001. Okay, we got the cables connected. Okay, now I'm going to do the thing I always like to do before I proceed with the lab. I'm going to just give these guys host names. The switches, I won't have to do any no shutdown commands, but on the two routers, I'm going to do a no shutdown command on those two G001 ports. And then I'm going to just show CDP neighbor to make sure the wiring was okay. And before I do that, I'm going to go ahead and click on this topology here, and let's correct that label, because that's supposed to be R1. And this router is supposed to be R2. And this switch is supposed to be, hi, we're taping, go on and have a seat. We're taping, and then we'll actually do it for real. This is going to be switch 1. And this is going to be switch 2. Okay, so we now have the R1, R2, S1, and S2 matches the printout on the front of the lab. And let's pop back to the logical view for 1 second, and let's make this line up what's on the lab here, because he kind of scrambles them and puts them there. So I'm going to put them in a line like it shows on the front page of the lab report. And now the logical view is more like the physical layout. But I'm going to go back to the physical screen to actually do the configuration now. Okay, so in Packet Tracer, these devices are always erased by default. On a real device, using an actual real device, we have to make sure that it was actually erased. So for example, I've got, here's two real routers connected together here in the lab, in the physical lab. I've just got them plugged together straight from the switch in the middle, and they look like they're erased because it says, do you want to go into the initial configuration dialog? And routers only say that if when they start up, they see no startup configuration. So if we were using the real devices in the lab, it would work in that case. Okay, so I'm on page 2 of the report, and we're going to go down to, we've completed part 1, step 1, and we've cabled the network as shown. And now we're going to go to step 2, and let's configure basic settings for each router. And I put a few questions in here, so you have something to answer and write your name on when you turn the lab report. So I'm going to go to the first router, R1, and go to the CLI. And let me blow it up just a little bit here, so it's a little bit easier to see the whole screen from side to side. And I'm going to click the top on here so that I can pick it and have to do this every time. Okay, he appears to have, look at this, do you want to go into the initial configuration dialog? He appears to have no existing configuration. We can check on that for sure. We can go to the privileged exec mode and we can show it, ask him to show us the startup configuration. There's no startup configuration for this device. So we're going to start to configure it. So the very first thing I like to do is I'm going to go to the global configuration mode, and I'm going to give this guy a host name of R1. I'm going to skip ahead slightly. I want to check, this is not in the lab, but I like to use Cisco Discovery Protocol to show that all the devices are actually plugged together like you think they are, because in a big complicated rack with lots of stuff, you might transpose a wire somewhere and you don't have it quite the way you thought it was, and you don't get the right results when you do the lab. Okay, so I'm going to go to the interface, gigabit, G0/0/1. Oops. I misspelled it. Interface, gigabit. I already said gigabit, 0/0/1. I'm doing that shutdown. Not giving an IP address yet. Later on, we're giving IP address, but we don't need this now. Cisco Discovery Protocol is a data link layer technology. It doesn't need any IP addresses. It just works. Just plug the Ethernet cables in, do a no shutdown, and CDP is going to work for you. Okay, I'm going to skip now to router R2 because we're going to do our CDP test first. I'm going to skip to R2 and go to the CLI, make it the right size, and click top so that I don't have to resize it again next time. And we'll go to the privilege exec mode, and then we'll say host name R2. We'll go to configuration mode. And R2, and then interface gigabit 0/0/1. Let's do that no shutdown. So that should fix that where it'll show up later when we need to check it. And we'll do the same thing on S1. We'll go to the CLI, click top, lower it up just a little bit. And I'm going to go to the privilege exec mode and then go to the global configuration mode and give this guy a host name of S1. We don't need to do any node shutdowns on the switch because all the on the switch is up and up by default. And then I'll go to S2, go to the CLI, I can stay on top, and then go enable, configure, terminal, hostname S2. Now let's start with S2. S2 is the man in the middle here. I'm going to go back to the privilege exec mode. And let's show our CDP neighbors, and it might take a few seconds for this to show up. So S2 is showing us that he's connected to R2. R2's gig 001 port is connected to R2's G05, and that's what the line diagram calls out for. Now I'm going to do it again here because we want to wait for that switch to show up and turn back into S1. That takes about 60 seconds. And it says that switch, he's still got the default host name of switch. That's S1. Port 1 is connected to port 1 of the switch. Port 1 of our switch is connected to port 01 of the switch over there. Okay, good. It was more than 60. CDP advertisements are about every 60 seconds. So now he's telling me properly he's connected to S1, he's connected to R2. And if we went back to switch S1, which is sort of in the middle, let's go back to S1, go to the CLI. I thought I clicked top on that, but it can stay that way. R1, S2, S1, okay. And let's do a show CDP neighbor. So S1 is also connected to S2 from 1 to 1, and S1 is connected back to his router R1 through S1's port number 5 goes to the gigabit 001. And it shows you, oh, it's an ISR 4300 router, 2960 switch. So Cisco Discovery Protocol gives you lots of useful information. Okay, so let's skip now and go back to, we want to go back to router R1 and start configuring this. Okay, I configured router 1 as R1. I'm on step 2, little a. I already configured router 2 as R2. So now he's going to have us do, I'm going to do these following 4 steps, B, C, D, E, and F. I'm going to do them on R1 first, and then I'll flip over to R2 and do them sequentially on R2, so I don't have to click back and forth between screens so much. So we're at R1, and we're supposed to say no IP domain lookup, so I'll go to the global configuration mode and say no IP domain, which will prevent any errors that we type in misspelled commands from hanging the machine up. Then enable secret class. Line console 0. Line console 0. That's Cisco. And enable logins. And then we're going to go line VTY 0 through 4 and repeat these commands, password Cisco and login. So now the console is protected with the password Cisco. And if you come in through secure shell or anything of that nature, that's going to fix this as well. Okay, hold on here. Oh, good, we're getting some remote attendance. So let me update my attendance sheet here. So he is remote, and he is remote, and hang loose. Big Brother software, report to me what's going on in the room. And also, now I did it, B, C, D, and E, and now we have to encrypt the plain text passwords, and that's the command that, focus back to this, service, password, encryption, will keep those words Cisco that would normally appear in plain text in the running configuration. It'll slightly hide it. So to illustrate it, do show run configuration. See that the enable secret class encrypts the word class very heavily. It's MD5. It's very difficult to reverse engineer. This is level 7 encryption on the word Cisco and Cisco line. It said password. I typed password Cisco, and now we see 7. That's a lower level strength of encryption. You can go to many places on the web and reverse encrypt that, but at least someone can't look over your shoulder and instantly see what the password is. So that's some form of protection against that. Okay, now I need to go and pop back to R2, and repeat this. So I'll minimize him. I'll go to R2. See if I can keep him on top and expand it. The only thing we done on R2 so far is we gave it a host name, and I did the no shutdown on that gigabit port, so Cisco Discovery Protocol will work. But now we need to do this B through F again. So configuration mode, no IP domain lookup. Oops, he didn't look up. No IP domain lookup. Too much abbreviations. Enable secret class. Line console 0, password Cisco, allow logins. Telnet lines, BTY 034, Cisco, allow logins. And then go back to plain configuration mode and do a service password encryption. Okay, we've completed all the steps on page 2 of the lab. Now we're going to go on to page 3. Okay, the only 2 basic configuration steps that are left on these 2 routers is to do the warning, the message that the lawyers of your company told you to say. We can't say welcome anymore. We got to say get out of here, you. So I'm going to do it R2 and not back to R1. So configuration mode, banner, message of the day, authorized users only, whatever your legal staff tells you to say. And then let's do a copy run start and save configuration. Okay, now can I pop back to R1 now and do this? Here we go, here's R1. So we're gonna go take your terminal, enter message of the day, authorize users only, and copy run start, and they're saved. Okay, now we're ready to do some configuration on the switches. So I'm going to go to switch 1. Switch has basically no configuration yet, all except the host name, so that CDP would work. We're going to do a very similar setup on these 2 switches. I already gave them the host name. I don't need to do. I'm in the middle of page 3 where it says step 3, configure basic settings for each switch, and I've done little A already. Now let's do B. So I'll go to the global configuration mode on this device and say no IP domain lookup. So any misspelled commands don't hang us up. Enable class, line console 0, password Cisco, and login. Then line BTY 0 through 15, because the switches have like 16 incoming connections and routers have 5. Although you can get later IOSs that will expand that. Password Cisco, login. Okay, I'm going to repeat all these steps now on switch S2. So I'll bring up S2. We've already given it the host name. Go to the configuration mode. No IP, domain lookup. Enable secret class. Line console 0. Password Cisco. Enable logins. Line BTY 0 through 15, password Cisco, and logins. Okay, I've completed everything to the bottom of page 3, and then he's going to have me do a couple of more commands here. And there's some answers to fill in when you're doing the lab to turn into me on this. I'm going to go back to S1, and then I'll come back and do it on S2. So back to S1. Oh, at the very top of page 4, he says, what is the command for encrypting the plain text passwords? We just used this a second ago on the router. And look back at that page, and you would see the global configuration mode, and it's service password encryption is the command to do this. And we're going to do a banner message of the day. Sign authorize users only, and then a compliment start. And then we'll repeat this on switch number S2. So go back to peer configuration mode, service, password encryption, tab completion, makes me super fast type. Banner message of the day, sign author, users only, and then let's save it. Okay, we've configured S1 and S2 fully now, and actually they're just being passed through switches. You could actually perform this lab by simply plugging an Ethernet cable between R1 and R2. And everyone that's here in the lab, that's what I'm going to do, because we're sharing the lab with another class where they've already using the switches and another configuration. That just makes it a little easier on us here in the lab. Okay, we're ready to go. I'm at the sort of the top third, page 4, part 2, big part 2, step 1, and we're going to configure some IP addresses and the OSPF configuration on each router. So let me pop down and go to router R1. And we're supposed to go, now, when you do this with Packet Tracer, you guys that are remote, you're going to use provision 1 of the 4000 series labs, and you're going to type interface G0/0/1. When we do this here in the lab, we have the model 1941 routers, and in other words, this interface is G0/0, just two numbers, and G0/1. So when you do, if you're here doing it in the lab, I wrote a big thing on the board, be careful, don't use G001, just use G01, because otherwise you'll get an error because he doesn't recognize that numbering scheme. Okay, so I'll go to the global configuration mode on router R1, and I'm going to say interface gigabit 0/0/1. And I'm going to give it an IP address of 10.53.0.1 and a /24. And the question on the third one was no blank. What do you type to activate the interface? That's the command that I had to type a second ago to make the interface active so Cisco Discovery Protocol work. That's no shutdown. I already typed it, but I'll just type it again. If you do no shutdown, you type no shutdown again, it still remains enabled. Then he says type the word exit to back us off 1 level. And then we're going to say interface loopback 1. As a reminder, loopback ports have no physical presence. They're like the 127.0.0.1 on your desktop PC that you can ping as a test. And we're going to create it as a to have an additional address to ping in this lab. And also OSPF will use the loopback port as an alternative to the priority, OSPF priority command. It's a stable port. A loopback port will never go down even if you pull the wires out. Whereas a physical Ethernet port, I can make it not be up and up anymore. I can pull the wire out of the port and it won't stay up anymore because it has to have the wire to do the keep alives through. So this IP address is supposed to be 172.16.1.1, and we're giving it a /24 address. Could give it a host address, could be all 255s, but he's telling us to do this. Okay, I will now skip to R2 and enter the proper commands for R2. We need to be in the global configuration mode. And then we're going to say IP address interface gigabit 0/0/1, and then give an IP address of 10.53.0.2. The first one was .1. Okay. And as a peer test now, I should be able to ping. He doesn't tell us to do this. I want to ping 10.53.0.1. Do I have a connection across that link? Yes, it worked fine. So the first dot is the failure timeout. Our address resolution protocol will typically kill your first or second ping response, but then after that, it's fine. I'm getting the exclamation mark, which is good. Okay. Let's see. I completed everything on that section, and just to check, I'm going to do a show IP interface brief is the command they usually give you in the lab. Oh, I didn't do the loopback port. I didn't do the loopback port yet. I got to do the loopback port on R2. Okay, so configure terminal, interface loopback 1, IP address 192.168.1.1. That look like a firmware IP address to you? That's, oops, I fat fingered it. IP address 192.168.1.1. That's the same address that most people's home routers have. The show IP interface brief. It looks 10.53.0.2. I'm looking at the front page chart and 192.168.1.1. Everything's up and up and up. I like this alternative command, show prot for show protocol, because it shows you what show IP interface brief does not show you the subnet mask. It only shows you the network address. But show prot gives you the slash number, so now you can see that the address and the network, the prefix is proper. Okay. All right, now we're instructed in part 2, step 1, little part B, with down the bottom third or quarter of page 4 of the lab report. We're going to turn on some OSPF processes, and he has us do it on R1 first. I'll go to the total configuration mode, and we're going to say router OSPF 56. In the lecture, I said why. You can use 1. That's a process ID. It's not like EIGRP where the numbers have to be the same. It's not an autonomous system number. With those, EIGRP is no longer in CCNA, but if you said router EIGRP1 on R1, you'd have to say router EIGRP1 on R2, or they wouldn't contact each other. But OSPF is a process ID, and we're going to use area numbers instead of autonomous system numbers. So when we go to the network statements to bind the OSPF process to the network interfaces, we're going to, at that point, that's where we're going to say area 0, and those must match. And in CCNA, as is currently, objectives currently for CCNA are single area OSPF only. We used to have a little bit of multi-area OSPF in CCNA, but that's been moved back up again to the CCNP. Okay, I'm supposed to do the same thing on our router 2. So I'll go to the configuration mode and say OSPF. I'm sorry, router OSPF. It doesn't have to match. But some people are superstitious and they just make it match. They don't have to match. The area IDs must match. Okay, now we're going to do some binding of network interfaces. Oops, first of all, we're going to put in the router ID. So router ID is 1.1.1.1. And remember, the priority process, I put in a loopback port. And if I had not just typed this command here, router ID, the router ID of router R1 would have been that loopback address, 172.16. Router B's second router would have been the 192.168. But it's considered best practice now, since they put this router ID command 10 or 15 years ago, to use the specific router ID value instead of depending on a loopback port. Loopback ports are fine, they're stable, they never go down. But router ID is what they currently recommend. Okay, now I'm going to pop over to router R2. And router ID, PM for him is 2.2.2.2. Okay, now we're supposed to go back to router R1 and configure a network binding statement. So if you remember the networks that were attached to this, do show protocol. It was a network 10.53 and 172.16. So the first thing he's going to have us do is bind the network 10.53.0.0, which normally would be 255.255.255.0, but we're supposed to put in the wildcard mask instead. So all the 255s turn to zeros and all the zeros turn to 255s. It's the mirror image, and we get 0.0.0.255, and then we have to put in area 0. Some of the older iOSs will tolerate you putting in the actual subnet mask, and he will convert it for you. Next time you do share run, he'll convert it back for you. Now, is it going to also have us bind? He's not having us bind that loopback port yet. I think on one of these routers he doesn't do it. On one he does on the other. So let's pop back to R. I'm at the top of page 5 now, and we're supposed to go to router R2. And we're supposed to get the network statement of 192.168.1.0, 0.0.0.255, area 0. Oops. .192.168. .1.0. I didn't type in that dot there. Blue is blank. 0.0.0.55 area 0. Or he gives you an optional command. This is a vestige of the old IP. We don't have to do any IPv6 configuration anymore in routing protocols. But there's an optional way of going to the port, and he, for example, I could specify interface loopback 1 and IP OSPF 56 area 0. I could do that. Now let's see. I think I forgot to do the very top line, which was network 10.53.0.0. 0.0.0.55 area 0. There we go. Okay. Now, little f about the quarter down from the top of page 5. We're going to show our IP OSPF neighbors. Look at that message that popped up on the screen. It went to the full state. It typically takes a moment for this to take place because they have to go through the process of sending the hello packets, finding their neighbors, determining who's going to be the designated router if it's a multi-access network, sending the topology jigsaw puzzle pieces to the designated router, waiting for the designated router to send all those pieces back to everybody else so everyone has the complete roadmap. The same maps go, the exact same topology is in every router's individual RAN, and then each router individually calculates his own routing table based upon the best path from where he is to every other point in the network. So I should be able to type show IP OSPF neighbor, and I can see that my neighbor is I have a full with the full state, and my neighbor is the DR. Okay, now this other command that they did in the slide, I'm going to type it instead. Show IP OSPF interface G0/G0/1, and I like this command because it shows us that this router is the BDR. And he shows us that the designated router is the 1.1.1.1, the other ID. So it gives you a little bit more useful information. But the classical command to first start troubleshooting with in OSPF is always show IP OSPF neighbor. If your neighbors don't show up, there's some problem. The IP addresses didn't have the right subnet mask, or the area numbers didn't match, or something like that. You got to go back and do some troubleshooting. So this works fine. So the router in this case that was identified as a designated router was the 1.1.1.1 one, and the one that was a backup designated router was a 2.2.2.2. Now, let us look at the little g. We're going to type show IP route. I'll just type the basic command. Show, it's supposed to be on R1. Show IP route. And we see our directly connected networks, the 10.53 gigabit link to the other router, which progresses through the switches. Switches would just be in the middleman. You could plug them straight together with one wire and not use two switches. It would look exactly the same as this. And then O is a route, not a locally connected, directly connected route to this particular router, but it's a route that's one or more hops away. And that's the loopback port that's present on the other router, which we told to advertise that 192.168.1.1. So from R1, ping 192.168.1.1, and hey, it works. And there wasn't even an ARP timeout. Okay, so we have basic OSPF connectivity here between the two of them. If we type the command show IP protocols, see all the routing protocols are running, we can see that this is OSPF process number 56, and that we're routing the network 10.53. On this router R1, we did not bind the loopback port, so he's not being advertised. We're only binding that 10.53 network, so that there will be no connectivity and ping between router R2 will not be able to ping that loopback port for R1 because OSPF is not advertising it. Okay, bottom of page 5, we're going to optimize the single area OSPF configuration. We want to make sure that R1 is a designated router. And I think R1 turned out to be the backup, and R2 turned out to be the designated one. Okay, so we're going to go to R1. We're going to go to the global configuration mode. Base gigabit 0/0/1. And IP, this is the highest priority, interface priority, OSPF priority 50. Default I think is 128. And now we're going to mess with the timers. Oh, this is bad magic. We shouldn't do this in the CCNA level. But he's trying to illustrate to you that if you change the timers on one particular device, if you don't change the timer on the other device as well, they'll drop out from each other. So there's a slight misprint in the lab here. The two first lines that say R1 are correct, and the second two lines, they should both say R2. Above little letter C, those both should be R2. The misprint is the bottom one says R1, not R2. Okay, so let's proceed as if everything was going really well. I'm already at interface G001. I'm going to say OSPF hello interval of 30. And now we're supposed to go to R2 and do the same thing. So go to R2. Global configuration mode. Interface G0/0/1. IP OSPF priority 30. Now, very important concept here. Most companies have smaller routers, like the routers we have here in the lab are about $1,000 a piece. The switches are about, notice that the timer's expired. I change the timer, and it'll take a few seconds before they come back up again. The two guys will reestablish their adjacency with each other shortly, because I changed their priority values. Okay, what we want to do is we want to the connection that goes to our internet service provider, or maybe back to our home office, which has the big expensive routers that have hundreds of thousands of entries in them. We can't put those hundreds of thousands of entries in our little bitty $1,000 routers. It would swamp them. So what we have to do is establish a default route, and OSPF will take care of all the connectivity between the dozens or hundreds of routers we have within our company or enterprise. And then the default static route will take care of the connection back to the internet service provider or the home office. And that way we don't have to go to a dozen routers or 100 routers and put a separate route, a static route in each one of them back to the home office. We'll create a static default route on one of the routers and use OSPF, which is a routing protocol that propagates routing information to other routers anyway, and have it also propagate this static default route. Okay, so we're going to go to, I see another misprint here in the lab. We're going to go back to router 1. And we're going to create the default static route. Let me go back to the pure global configuration mode. So this is the standard classic quad 0. And our loopback one is being used as our fake ISP. He's warning us. It's a route without a default, without a gateway, but he took it. And then we'll say router OSPF 56, our proper. And the default information originate will tell it to propagate that information to the other routers. Now also on R2, just to tune it up a little bit, because right now he's using 2 Ethernet ports and he doesn't know if there's other routers connected to the same Ethernet switch. So he's treating it as a broadcast multi-access, and he has to elect a DR and BDR. Well, if we make it a point-to-point network, you won't have to do that anymore. Okay, so I should be on R2 right now. I'm still on R2. I'm going to go to interface, terminal, interface, loop back, network 1, and IP OSPF network point-to-point. And then on R2, I'm also going to make that a passive interface because that's going back to like employees' desktop, employee PCs. There's no more routers that way. And that way he won't waste a bunch of bandwidth sending out hello packets and topology updates out that port, but he will advertise that Ethernet network of employee PCs to the rest of the network so that they have connectivity. So let's see, router OSPF 56 and passive 8 loopback 1. Okay, now he's going to have us change some bandwidth values. Let's go back to R1. I want to check to see, did our neighbors go away? Our neighbors going away. We changed those timer values, and he never had us fix that. So I'm going to fix that so we get our adjacencies back, so that the routing tables will be up to date here. So I'm going to go to R1 to the interface G0/0/1 and say no IP OSPF hello interval. I'll do the same thing on R2, and maybe that'll fix it. Configure terminal interface G0/0/1. And no IP OSPF hello interval 30. Oh, show IP OSPF neighbor. Ah, I got my neighbor back. Okay, good. We need the neighbor because we need it to be working. Okay, I'm going to go down to the bottom third of page 6 and do the little step F now, and I'm supposed to be over on R1. And he says show IP OSPF neighbor. So 2.2.2.2 is now the BDR. We changed that with the priority command. If I do show IP OSPF interface G0/0/1, you can see that the designated router is the 1.1.1.1, and the backup designated router is the 2.2.2.2. We forced that by using the interface priority command instead of being an accident of the loopback ports that were there. Because we told the router R1 to have a router ID of 1.1.1.1, and we told router R2 to have a router ID of 2.2.2.2, and which one of these is a higher value? 2.2.2.2 is higher, that's why he became the designated router. No, we want R1 to be the designated router, so we can change that in that fashion. Okay, now we're going to do some, we're going to tamper around with bandwidth here. I'm going to go to R1, and I'm going to go to the configuration mode. I'm going to say router OSPF 56. The auto cost reference bandwidth of 1000. And please ensure reference bandwidth is consistent across all routers. Okay? And now we're going to go back to the privilege exec mode and type clear IP OSPF processes because we changed the calculation of the metrics. He's going to warn me. Oh, warning Will Robinson. Do you want to do this? Yeah. So we're going to lose this. And while he regains his census there, I'll go to R2 do the same thing. So these reference values must agree, or you will get weird metrics calculations and you won't get what you expected to get. So I'll go to the configuration mode on router R2 and say router OSPF 56. Auto cost reference bandwidth 1000, so they're the same. And go back to the parental privilege exec mode and type clear IP OSPF processes. Warning. It'll take a second for the adjacencies to come in. Okay, they came back. Okay, we're supposed to be at R1 now. And here he's going to use the command that I really like. It shows you one sort of at a glance. I like the commands that show you sort of at a glance, but I have the type 2 commands, what's going on, like show interface status on the switch. Will show you which ports are in the VLANs and which ports are trunking ports. Normally I've typed show interface trunk to see the trunking ports. Normally I've typed show VLAN to see which ports are assigned to particular VLANs. So we're instructed at R1 to type the command show IP OSPF interface G0/0/1. And he tells us that. Now notice that the printout on mine, this packet tracer doesn't exactly match what's in the printed lab. And if you do this on real equipment, different versions of iOS will sometimes slightly differ in what they do. But we have the important stuff we need here. We know now exactly who the designated DR router is. We know exactly who the backup designated router ID is. We see that the timers are the hello timer is 30 seconds. The dead timer by default is 120 seconds. I'm sorry, on this one it's 10 seconds because it's a fast Ethernet network. The dead timer is 40. So when I changed that timer to 30, router R1 went to 30 and router R2 was 10, and they lost connectivity and they went down and down with each other and had to come back. I had to make it back to the default, make them both 10 before they came back. Okay, so in the middle, down in the middle of page 7, little letter B, we are instructed to type the command show IP route OSPF. IP route normally gives you the whole thing. If I type show IPF route OSPF, it just shows you the OSPF line by itself. You'll get the legend and it saves a little bit of space. So we should say 192.168.1.0 is what in the lab report we're getting that. Yeah, the administrative distance is 110. The cost is 10. Everything looks copacetic there. Now let's go to router R2. And first of all, I'm just going to type the command show IP route, the normal one. We can see that the gateway of last resort has been set, because normally this will say gateway of last resort has not been set. Well, let me do it on R1 to show you that. Normally it would say something like gateway of last resort has not been set until you create this. Oh, R1 was our gateway of last resort was set from that router that was connected to the loopback port simulating ISP or home office. So R2, notice on R1 it showed that the default route was S star. That's the line connected to this router. This physical wire goes to the ISP or the home office. Now OSPF is going to propagate that to all the other routers. So instead of typing one line on 100 routers, would you rather just type 2 lines on one router and have all the other routers automatically get this information via the OSPF process? Yeah. Here's our default route. All the others around don't know about it. It doesn't say S star. Only says it on the real router that actually is physically the one wire connected to the ISP. It says OSPF type 2 external route is what this means, but it is a default route, and it does tell us that here's the way to get to that default route. Just go to that IP address on that router, and you will be able to talk to your ISP or your home office. Now, from R2, we're at R2 now, should I be able to ping 172.16.1.1? And I can't ping. Question, he says, why is the OSPF cost for the default route different than the cost of the old one? Well, it's because type 2 external routes keep the same cost. You don't have to answer that question, the answer is already printed. So there are a few questions you did have to answer on this lab before you turn it into me for a grade. And on page 2, the questions about how do you assign a device name to each router, that's the word command host name. There was a question on page 4, 4 questions on page 4 about what's the command to encrypt the plain text passwords, that's the service password encryption. And what's the command that saves the running configuration to the startup configuration file? Copy run start. It's copy running dash config, startup config. You can abbreviate that to copy run start. Then in part 2, after you do the IP address, you have to type a no shutdown for both R1 and R2 to make those ports go up. And let's see what other questions will be in this lab. Okay, that's it. All right, now that's it. I've covered everything in this lab. Hang loose. I'm going to stop the recording.